Hello, my name's Paul Haig. I'm restoring a 1966 Lotus Elan Series 2, and in this video we'll take a quick look at the drive chain. This is the Lotus Twincam engine. It's 1558cc. It's a cast aluminium cylinder head and cast aluminium front cover mounted onto a cast iron engine block. The engine block is manufactured by Ford, and the cast aluminium head and front cover were purpose built, purpose designed for this Lotus Twincam application. So the cylinder head mounts on top of the block. So this is the cast iron block, which is a Ford part, and then the cast aluminium cylinder head on top, and this cast aluminium front cover which fixes to the front of the block. So Ford down here, Lotus on the top. Can I do this with one hand? Yes. So those are the twin cams. Just going to put this down. There were three different sets of cams that were used during the production run of the Twincam. Type B, which these are the original ones, Type C and Type D, and they progressively gave more horsepower with some changes to carburetors as well. So the power went up from 105 brake horsepower, 115 and 125 in the final type, which also had bigger valves in the big valve version. And the cam covers, so this cam cover design was changed over the years. So this Lotus script moved to the end during the production run, and the colours changed as well. So the originals, 105 brake horsepower, were blue, and then they went green and red, and the big valve versions were black. And I'm sure there are some other detail changes as well, maybe with the different carburetors and the ones that went to America. But in principle those four colours were used. The original block has got a camshaft in, which actually runs in line with that there. So it runs inside the block here, and it drives the oil pump, which you can see part of here, the fuel pump, which is here, and also the distributor, which will mount in there. So it retains the original camshaft from the original block as well, which is known as a jack shaft in this application. And this timing chain drives the two cams on the top, obviously, and this jack shaft cam as well, which are driven from the crank at the bottom. This is where the carbs will mount. There's two twin choke carbs, so in effect it has a carburettor per cylinder. And the exhaust manifold is a cast manifold on the originals and fabricated later on. There's the fabricated exhaust manifold, which fits onto the exhaust side of the engine and has to fit down in that gap there between the engine and the fabricated chassis. Incorporated in this aluminium front cover, so this is cylinder head, this is the front cover, is the water pump, which is turned by a belt that runs around the alternator or dynamo, and would turn a fan as well, which would cool the radiator. I think lots of people fit electric fans these days because the mechanical fan's not so great. But this water pump was seen as a bit of a weakness in the engine. I think the main problem is that if there is a failure with it, it's really difficult to get to, because you've got to get this cover out, and as you can see there's a cylinder head sat on top of it, which does not make it very easy to get to. The gearbox is a Ford unit as well, so that's the gear lever. It's a Ford Type 2300 gearbox, which is 4-speed, and it's 3-rail all synchromesh gearbox. Off the back of the gearbox is the prop shaft, which you can see if I shine the light in there. You see the universal joint in the back edge of the tail of the gearbox. So that runs through the chassis and joins to the final drive differential unit at the back. The differential unit has a Ford component at the front and a Lotus aluminium casing at the back. This particular differential has got a 3.9 to 1 ratio, so if I turn the prop shaft you can see the outputs to from the differential turning, and the ratio is would be 3.9 to 1. There were some different ratios which would give lower revs at higher speed in the later cars, and if I hold one of the outputs you'll see only one side of the diff turns. If you want to understand how diff works you have to look it up. Too difficult for me to explain, but it's beautifully simple. On the output of the differential we've got this flexible coupling. It's got this metal band around it which is only there when they're new and they haven't been in use. So when it's finally in use this band will get cut off. That's just to hold the rubber part in place before it's bolted together. So they are rubber flexible Rotaflex couplings, and they end up being known as donuts. They've got these metal pieces between rubber sections. So I don't know if it's possible for me to flex it. I'll try, but yeah, a little bit. So this gives the intermediate shaft, half shaft, which runs between the diff and the hub, the ability to change its angle as the suspension moves up and down. This is the intermediate shaft that will bolt onto the donuts at both ends. There's quite a lot of discussion about replacing these rubber donuts with a half shaft that's got constant velocity joints and the like at either end, because of worries about these rubber donuts failing and the consequences of that, which wouldn't be good. I'm going to leave these in place. They tend to wind up because they're rubber, so as you imagine the engine putting power on, before the wheel turns they flex, both of them flex, so they'll wind up a bit before the car pulls away, and it can give a bit of a surge as you pull away, which I guess is a characteristic of the car. And there's some comments as well that it will provide some shock absorbency between the road wheels and the drive chain, the engine and diff. I've no idea whether that's really necessary or whether it's a valid thing to say, but I'm going to leave them on this car. Racing Elans certainly wouldn't have these, they would have replaced them with a more solid system. And the intermediate shaft is not fitted to this car yet because there's no body on the car, so the suspension's fully down, so it's this is hanging down at the steepest angle. The hub's as far down as it can be, more or less, and if the intermediate shafts were in place it would be putting a lot of strain on these rubber donuts, so I'll only fit it once there's more weight on the suspension. The brake calipers are Girling calipers. There's no pads fitted in here at the moment, so it's fairly straightforward, but this section here might be unusual if you've never seen this system before. So this is the handbrake which operates on the rear wheels, and it's got its own pair of little pads in here, and it's operated by this rod. So I guess that was probably fairly standard in the 60s perhaps, but it's operated via this pivoting arrangement here. So the handbrake cable's at this side, and it pulls this mechanism forward which rotates, and it pulls the rods, so that in turn operates the handbrake. You need to keep all these pivots nicely clean and lubricated, otherwise the handbrake might not operate very efficiently. The rear discs are mounted on the hubs. It's interesting that in the original concept the idea was to put the discs on the outputs to the differential to reduce the mass of the hubs, because you want to have as low mass on the unsprung part of the car so that the wheel can react to the undulations in the road as quickly as possible with its low mass. So the idea was to put the brakes here, but they had to abandon the idea because when the handbrake was on, there's so much flex in these rubber donuts that you could push the car backwards and forwards a bit just with the flex in the rubber. So they ended up having to put the brakes onto the hubs. The wheels are steel pressed wheels, 2 parts, so outside and inside, and on this joint they're riveted together. It's important to know on these early wheels that this part here is flat, so where the tyre is located on the rim, there's nothing to stop the tyre being pushed off the rim. I think later cars or other cars have a ridge here so the tyre can't be pushed off. So if you're cornering really hard, you might be able to push the tyre off and it would deflate. So you've got to have inner tubes in these tyres. That would also deal with any leaks, I suppose, if there were any on the rivets. Pretty lightweight, so the tyre, rim and inner tube weigh 11.5 kilograms. So they're quite thin, and to have wheels in good conditions, it's getting hard because they are easily bent because they're quite thin. I think Sue Miller's doing new wheels with slightly thicker gauge, which will be a good option if you want to keep the original look. And it's held on in this case with a spinner. The early cars had 4 nuts, like many other cars do, and then later on you could buy it with this 1 nut or spinner in the centre, and the drive is through these pegs. Obviously the 4 studs would stop the wheel from rotating on the hub, but this 1 nut wouldn't stop it spinning or rotating on the hub. So these drive pegs are used to transfer the drive, and there's an arrow on this, you might be able to see on the film, saying undo in this direction, which this is only on hand tight, so I can undo it. So that's unusual because normally that direction of thread will be tightening. So this is a left-hand thread, and it's on as you sit in the car, the left-hand side of the car, which is correct for this type of spinner. If you were used to wire wheels and a different type of spinner, you might think that's on the wrong side, but because this spinner bears on this inside surface of the wheel, and it's important because the idea is to have them so that they're self-tightening if they were to come loose. Not sure I trust it, so you just make sure they're good and tight, but that's the correct direction. Left hand threads on the left hand side of the car as you sit in the car, right hand on the other side, obviously. If I take the wheel off, you can see it's quite a thin section. It's a 145 section, 13-inch wheel, which is a very narrow section wheel by today's standards. But the Series 1, 2 and 3 had this tyre fitted, and the Series 4 and the Sprint had a 155, slightly wider tyre, 13-inch still, and the body changed, the moulding changed so that you get the wider tyre underneath. But I wouldn't get I personally wouldn't get too obsessed about trying to get wider tyres on, because with the very good suspension geometry and the very lightweight car, the handlings and just the general ride is very pleasant. Softly sprung, lots of suspension travel, good road holding. Okay, pop that there. And you can see on the hubs, I don't know if it's clear in this light, but this is painted red, so that would indicate that it's on the left hand side of the car, and the other side, that part's painted green, just as an indicator. Okay, so that was a quick walk around the drive chain of the Lotus Elan, and there's the wonderful Lotus Twincam engine used in the Elans, the Elan Plus 2, Mark 1 Lotus Cortina, Mark 2 Cortina Lotus, What else? Mark 1 Twincam Escort, Lotus 7, and lots of racing Lotus cars as well. Okay, so I hope that was interesting, and I'm sure I'll be posting more videos. Thanks for watching.